renewable energy sources. As you know that now we are entering into the storage technologies. So first and foremost that why we need to have the storage system. You are getting the brief overview regarding this storage technologies, and that the storage is an important contribution for your renewable energy sources. Because you know most of them that you want to dependent on the is it fine? Okay. So you want to dependent on the renewable energy sources, and you want to make use of exploration further about this renewable energy sources, especially on means like that the focus is going to be on wind energy system or of solar energy system. These are of you know that the stochastic in nature, that they won't generate the constant power, constant output, that we will not get the constant. But what we are going to say that always that is the load is the master, source is the follower. We want to make it means whatever the disturbances at the source side, it should not reflect those disturbances at the load side. Otherwise, you know that what will be the consequences if the sources are not following to the requirement of the load. What will be the consequence that you will experience? Suppose that if you are taking the induction machine, either can be of AC machine or it can be of a DC machine. Okay, if the quality of the power is not good enough, so what will be the consequences? Can anyone of you? What? Oh, sorry. What will be the consequence if the power is not good enough to feed to either AC machine or of a DC machine? What will happen? And our loads are of which are of non-linear in nature. Most of the loads which are of non-linear in nature. Mm-hmm. Yeah. Yes, exactly what you are saying. Means like the rise of the temperature which is going to take place, and the performance of the machine is going to come down, and it is going to be, we will not, if you see the our lights itself, if it is of a flickering, we feel that it is of uncomfortable to the means that the people or of those who are working in the lighting area. Yeah, and then mind also there will be stress across your mind, and but you know it is more that you are means like swimming in the distributed energy sources, and you want to make it to promote in a bigger level, and then this the generation is okay during the peak timings or of when sunshine is there, that you can generate the more power, and then if it wind flow is more, that you can generate the more power. But during the night times or when the wind flow is not available, what you are going to do, that we can't shut down our loads or we can't shut down our office. Means like to increase, means like if you take the cases of some kind of industry, that the production also supposed to be maximized by using proper kind of power supply or of proper illumination, that it should be that the production can be maximized. How it can be made it possible? Okay, if the wind flow is not there, sunshine is not there, then obviously that you require to have the storage system. Okay, storage system is of mandatory. There are wide variety of storage system that we can talk. That the storage can be, yeah, as you know that you have the two types of power, AC power and DC power. Yes, and the AC, as you are obviously that you say that AC can't be stored. DC only, that is the only source that we can store the energy for long time, and it can be reused for your means for your application part. So in this DC also, as a means like what it is a kind of, after all it is a storage device. Means like what as a electrical engineer or of either power system, power electronics, or of some illumination engineering, what is their role to for this kind of storage technologies? Means like they will say that the chemicals, it is my profession, And then metallurgy, they will say that it is their profession as a battery or of some kind of fuel cell, and it is manufacturing will go to that side. As the electrical engineer, what is our role? Means like, as a power electronics, power system, this thing. But as a power electronics or of a power system plays a vital role. Okay, what is that role? Can any one of you, can you guess what we are going to have the discussion in this one? How the means like as a electrical engineer are going to support for the energy storage technologies. Energy storage technologies. That you are injecting power to the grid, extracting the power from the grid. Okay, then how you are injecting the power to the grid? You are means like that you are injecting the power means like either PV from PV side or of wind energy side, that you are trying to inject the power to the conventional grid. How means like you are going to make use of conversion. Yes, either you are going to make the frequency match as well as the magnitude match, then you will inject the power into the existing grid. By making means like what we can say that injection, it is of a somewhat you are going to make use of a kind of a converter, then match the frequency and the voltage magnitude, then you will inject and make your bit more stronger and stronger, okay, without dependent on the conventional part, and you will inject. That is well and good. You want to make it more stronger. Here also, that if you want to that your storage systems also wants to make you to be more stronger. I can store. I will means like there are you are hearing something like batteries. You are hearing flywheel energy storage systems, that you are hearing some kind of I posed the things superconducting magnetic energy storage system, even the electrolytic capacitors, okay, and also electrolytic capacitor, pumped energy storage systems. These are wide storage devices which are available. So then what we are going to do? Is there any role of the electrical engineers in this thing? That batteries, what is the role as the electrical engineers? Power fluctuations. Yeah. You know, any one of you, if you talk about this mathematical modeling, that you are aware about the mathematical modeling of your power means like batteries. Have you come across battery modeling, and then this kind of flywheel energy storage systems are of super capacitors part? Yes, and they will say that it is not come to your arena. Is it so? No, it will be under the part of the electrical engineer. Even though that the first the statement, what we can say that we are the that when I talk about the batteries, means I want to go depth about the means like that the different types of batteries. Means like you have the lithium ion, nickel cadmium, lead acid batteries, and some hydrogen batteries, that you are having the everything. That you know the good at fundamentals, I mean to say that. Okay, what's the best characteristic, that you are aware that batteries are good for are having the good energy density. Yeah, yes, and that characteristic that we are going to exploit for our application part. So this characteristic good enough, means like we can say that. Then apart from this one, I want to know more about the thing about the electrical engineering contribution in this storage technologies. Can you guess what supposed to be contributed to the energy storage technologies? If I talk about this thing, initially my students also, they were reluctant to do this topic, and it is not good enough to have more contribution to the this renewable energy sources. Is it so? Energy storage is a good contribution, or means like a bad contribution? Good contribution in which kind of sense? Improvising the potential part. Yeah, okay. Reliability, efficiency, then stabilizing the system, okay. Grid optimization, yeah, reliability, stability, grid optimization, efficiency, these are the contributing factors for enhancing your system. Yes, how you are going to achieve all these things? That next, that the fundamental question, how you want to achieve the things? Yeah, yeah, technology, we can say that it is a wide, the definition is so big for the technology. Here, mhm, mhm, okay, yeah, okay, yeah, stable, okay, mhm. Yeah, fine, good enough that the stabilization it is done. Now I am trying to grab the some points relevance to the electrical, means like that the towards my entry into the PPT. Mm-hmm. Mm. Okay. Yeah. Mm. Okay. That the chemical engineers will do take care about the improvising the energy density about the batteries and some anode or cathode. This development will be. Mm. Mm-hmm. Mm. Uh-huh. How you are proper optimization. Yeah, that the optimization, that what kind of optimization, you know that there are the challenges posed by the batteries, the challenges posed by the other storage system. What are the challenges? Means like each and every system that you can say that we are having the advantages and the disadvantages. Okay, every system is associated with the advantages and the disadvantages. This we will forget about the disadvantages part and focus on the advantages. How we can exploit, means like use those advantages, characteristics of storage system to our system. Okay, means like ours. So then, how now I will come to, after having the discussion, I can say that we'll move to the next level. I mean to say that the power converters are of very essential for the storage devices. Without power converter, there won't be any possibility of storing the energy. That you are talking about the power flow between the grid to the storage system to the grid, or from the grid to the storage, storage to the load point, or from the load to the storage, store to the grid point. These are, means like, what do you call, one way of flowing the power from source to the load, and from the source to the load to the source. First part is from source to the load, load to the source. What do you call the power flow? Yeah, that the concept is also there, but indirectly I am saying that it is like a source to the load and load to the source. But initially we will talk about the only one way, that is from the source to the load part. Source to the load part, it is of a unidirectional power flow we call it. And then that again you are having that the power flow from the load to the source side, will reversal of the power flow. It is like, you know, this is one way of doing the power transfer from one source to the other source, that we will say bidirectional power flow is there. Okay, and also here that the bidirectional power flow is good enough. Then what about sometimes that within the sources they do have fight among themselves, which one has to supposed to be contributed? How you are going to do that thing? Means like I am big boss, I am having more superpower, I can give the power to the load. Someone says that I am superpower than you, I want to give the power supply to the load, and I am deficient enough, I want to grab from you. Okay, then the power exchange among the storage devices also. How we are going to transfer the storage devices, that the power within the energy elements. Okay, these are the things that we are going to have the discussion in today's class. Okay, and if you can get familiarization that and also that the objectives of the work also what we are going to have, that we can see that. So, now the power electronics equipment plays a vital role for storing the energy as of now. What type of conversion, that the things that we are going to see that. So, if you see that the application can be of, now you are having my flow of presentation is going to be like this. Okay, I will take the, yeah, sorry, yes. Yeah, this one, that the introduction I will talk about, means here in the introduction I may take an examples of distributed energy sources or of the electric vehicles I can take, and the various types of energy storage technology that what we are having. Special focus on this flywheel energy storage system, superconducting magnetic energy storage system, and then supercapacitors, batteries, and this hybrid energy storage system, some kind of bidirectional DC-DC converters, how the power flow is going to be, and then some of the results that I will discuss, and at the end conclusion. So then now it comes to this type of storage technology, means like that the introduction and the review, this thing. None of the, means like they will say that these are of somewhat complicated, that you can't see the real time applications of this one, still under the maturity level, that the superconducting magnetic energy storage system. Some of the developed countries are working on this kind of SMES devices, still yet to come to the commercialization of this product. And you know that this flywheel energy storage system, it is a mechanical kind of storing the energy, but it well proven technology, that the flywheel energy storage system. And the problem, it requires the power electronics equipment as well for this flywheel energy storage system, how it is movement of inertia, that the concept, and the speed of your flywheel also it matters. So then, and then this supercapacitors and the batteries more popular. More popular means earlier, that is more popular is the batteries. Okay, then the afterwards that they are syncing or means combining with the supercapacitor part. Now you say something about, you are hearing for long time and long days about the battery, and also that you have the is there anything that with the batteries that we can proceed also, no? That the batteries, any issues with the battery storage systems? What issues? Okay, life cycle. Okay, yeah, life cycle of the battery. That is the fundamental reason that you are making use of, where you are making use, that the daily usage of your battery. Yeah, best example is the mobile phones. In the mobile phone that you are making use, for every 6 months that you require to replace the battery. Then what it is happening, that the performance on the first day of your purchase of mobile phone is not the same on the last day of your performance. What it is happening internally? Okay, then it becomes bulges and try to explode. Leakage or means like, you have you seen the leakage of the battery? Yeah, internal leakage, but external leakage you can't observe. Yeah. Then you will, if the internal leakage is happening, means that the bulging of the battery is going to takes place. Okay, it becomes bulges, and over the means never explode. If it explodes, what will be the consequence? then it is very dangerous. I mean to say that battery is like a bomb, okay, and you can't overcharge or means like over discharge also. The optimal usage of the battery. Yeah, 20%. There is some percentage prescribed by the what we can say that the manufacturer, according to the manufacturer, that we are going to make use of the batteries part. So that is the only how the means like internal operation is going to happen in the batteries. What kind of thing which is going to happen with the batteries? And even though that this is one problem that you identified and bring it to the notice to us, but still then battery is the more popular. Why it is so? Means like it is popular for distributed energy sources. Yeah, it can store, but there are some problems are there. Okay, that he is saying that internal leakage.
And also the life cycle will reduce after charging.
Yeah, that how you are going to estimate this kind of process when it is going to change the life cycle, and the performance on first day is not the same on the last day of your battery. So then how you are going to estimate? You require to have state of charge, depth of discharge, and then chemical degradation, right? That the temperature, working condition, yeah, contamination of the anode and the cathode. These things will be there. Blah blah. Means like these are the things that you can. But it is very complex to design the battery model. But simple that the battery models are there in our MATLAB and we do the experimentation. So we can't eliminate completely all these problems, okay, that we'll try to optimize these problems. How we are going to optimize the problems? If you make it, you know that when you are going to take your power semiconductor devices, okay, you have the what safe operating area, okay. If yes,
State of charge or temperature, whatever it will be,
okay,
flow of current,
mm-hmm.
we can optimize.
Yeah, that the state of charge that you will call it means like yeah, this is the thing. When it comes to the semiconductor devices, you have the stress across your switch, voltage stress or current stress. If you increase the stress, what happens? Then the performance will go down. Here also the same thing in the case of this kind of batteries, that it should be optimally utilized. That the professor rightly pointed that we are going to make use of the batteries in the steady state conditions, okay, not in the transient condition. Transient condition, why not in the transient condition? That you will have more fluctuations, okay, that the fluctuation, that the transient period exists for short period. With short period, it demands more power from the source. That the battery means like you know that you are making me to run at my speed is limited to 10 kilometers per hour. Okay, if you are making me to run for 100 kilometers per hour, it is not possible. Similarly, it is the case with the battery as well. Okay, if you want to take the more power, that it can't. My stability is like this only. I am very arrogant to, I won't react to any of the loads. That is the nature of the battery. Okay, and now when it comes to the one more thing, this is the battery part. Now we'll comes to the supercapacitors part. Okay, in this yes, I can make you to the, I will come supercapacitor part. In this supercapacitor part, what is it different from the electrolytic capacitor, that the supercapacitor? Many people, how many of you are working in this storage technologies? Is there anyone?
Yes, I am using as a backup for my system.
Yeah, yeah, I can understand. It is not yet mature. You know, I got here because of these things only. Okay, I mean to say that it is 20, 25 years back, it is there in Europe. Okay, they are making use extensively for their application. Now you say that the supercapacitor, is it different from the conventional electrolytic capacitor, or is it the same? Yes? Is it different or of same from the electrolytic capacitors? Yeah, yeah, high power density. Yeah, that I can obviously will say that it is of high power density. What's the internal structure? Means like if you see that the name itself we are calling as a super. Super means like you are superconducting. We are saying some superconductors also that you heard in your studies. Yeah. Yeah, obviously, but not completely zero resistance, but milli, micro ohms of resistance is present. Okay. I- Yes, offer less resistance is there. That is one. If resistance is lower, then what is the advantage? Losses will be reduced. Okay, we can pass more current through it. Okay, and with thin wire that we can more hundreds of amperes of the current through that thing. Yeah. Here in the case of the conventional electrolytic capacitor and the supercapacitor, the basic difference is that the presence of dielectric medium. Okay. In electrolytic capacitor, you will find the dielectric material C equal to epsilon naught A by D. Okay. That the area is going to be more in the case of electrolytic capacitor. In the case of supercapacitor, this dielectric medium is absent. That you will have the means the capacitance is proportional to the area of the surface. Okay. Then you will have the wider area. Now at the maximum for your transmission, distribution in power system domain, that the capacitance, electrolytic capacitance at the maximum that you will find the millifarads. Okay, you can't get more than that millifarads, hundreds of thousand of millifarads that you can. But in the case of supercapacitor, it is in terms of the farads. Okay, 58 farads, 58 farads is of we are working on that. Okay, that is the one beauty of the capacitance. But the problem is there that the electrolytic capacitors are rated for your line voltages, but the supercapacitors is not so, that the rating is very. And another problem also will be there, and every system that I am saying that it is associated with the advantages and the disadvantages of the system. Okay, that will take the positive aspect and forget about the negative aspects of it. And my as a means like as a power electronics, power system engineer, electrical. Basically, I will talk about the electrical engineer. What is our role? This is the manufacturing side, and physicist will say that we will manufacture, and what is your role? And then chemistry they will come, and it is my role. We will manufacture. Then what is our role? That the usage, optimal usage, how we are going to control the charge and the discharge cycle, state of the charge, depth of the discharge, and how we are going to optimally usage the contribution of the power level by the supercapacitor at the required circumstances. That can be dealt by the power electronics engineer. And the power flow also, that you are telling about this, the concept like vehicle to grid to the vehicle concepts. Okay, almost all the electric vehicles are fitted with the batteries, and then you want to harness the energy from the sun, or from the means like sun only, then you require to store it. That the storage. Another thing also that I want to say that that the electric vehicle usage, is it the same that during your starting condition and at running at the rated speed, that the vehicle is going to consume the same amount of power, starting condition and during scheduled speed or of rated speed? Does it consume the same amount of power? Starting is high because it is going to drag. Huh? Yes, to overcome means start from the 0 kilometers to the up to 60 kilometers per hour, like that. It is means like takes more amount of current from the source part. And if you then after reaching it, just to maintain the speed, means like we have to maintain the voltage level. Okay, for that means like battery will come and support that part. But during from starting from the rest portion, that you require the huge amount of current from the source side. That can be delivered. Battery, we will say that it can't be delivered, and that's the reason that the speed of your vehicles are of, what's the speed of the vehicles, electric vehicle speed, maximum speed 25 kilometers. Okay, you can't go behind that thing. And now these people are there, European and American, they will have the mature technology. Then they are working on this thing and they are making the speed like 150 kilometers per hour and the 200 kilometers per hour. So that understand. Then if we have this kind of technology, something like hybridization, that initial transient can be taken care by your some other source, then we can enhance the speed of the vehicle. Okay, this is what that we can see. So now actually I will enter into the topic. So this is the introduction about the introduction about the DC microgrid architecture and the special focus. All the time means we are focusing mostly on the DC microgrid structure. Okay, all your electric vehicle means like this DC microgrid. Why we are focusing is that the energy storage is going to happen in the form of DC only. With that intention, that we are making use of the DC microgrid for our application. So electric vehicles are promising alternative to the conventional vehicles to their environmental friendliness and higher efficiency. You want to means working that the theme of the GAN course also to reduce the carbon emissions, uh, net zero concept, to reduce the losses, this one. Even though electric vehicles came to the market, they face lot of challenges in replacing the IC engines. Still today, complete electric vehicles run with the electricity, we can't see that in association with the IC engine, that we are seeing that. And then pollution caused by IC vehicles are one of the important regional global warming, ozone degradation. So every countries are pushing themselves to sustainability. Even our mission of our government also to promote more and more electric vehicles to the market, and they are giving the subsidization on this electric vehicle to make them the the people habituate to the usage of the electric vehicles. Then environmental impact of electricity sector led to the widespread usage of the renewable energy sources. Special means like this one also, what we can say associated with that everyone that you are making use of the rooftop solar power generation and small windmills, means like wind is not that much I can see that in our region, but the solar self-sustained one, means like government is providing the subsidy for installing the rooftop solar plantation. That is, and it requires anything that if you take this one without storage, we can't imagine the sustenance of the system. Without storage, that we can't imagine that the sustenance of this kind of system. So we require the storage. Without storage, you can't imagine this distributed energy sources. These are of stochastic in nature. Then our system also will collapse. Then stochastic behavior of the renewable energy sources, many issues with the stability, reliability and the power quality is that. The issue of uncertainty with the renewable energy sources can be addressed by integrating with the energy storage technology, that we are going to have the things on it. So this is the complete DC microgrid, generalized DC microgrid architecture, that we have the different types of distributed energy sources. If you take the fuel cells, battery also can be considered, supercapacitor energy storage system, and then micro, hydro, electric power plants, PV plants, wind plants, and the terminal to AC grids. And some of the applications, what we can say that basically that the first part will be the electric vehicles charging infrastructure development. You know, here also when it comes to the electric vehicle charging infrastructure development, you can charge your electric vehicle by taking the home power supply, power supply. So then what it is going to happen? Can we charge with your household means the household power to charge your vehicle? Yes, of course, we can charge. After all, it is electricity only. Then we can charge from our house also. But why specifically you require the charging stations?
Large amount of current at that time.
Mm-hmm.
Because of that, the voltage fluctuations will occur around the area.
Okay, fine. Then there will be a dedicated substation for you to charge your fleet, means hundreds of vehicles. That there will be a dedicated substation, you can charge the things. It doesn't mind. Okay, I will give the separate power supplies to you. You can charge the vehicle. Then what's the advantage of, means like household? My question is that in this way, that from house also that you can charge your vehicle, or from the means a separate charging infrastructure that I want to have for this one. What is the motto of establishing the time? Time is one factor. Yeah, means time in the sense that if you increase the current rating, obviously that the charging is going to come down. That is the intention of having the high current, means like that the type of power supply is going to be like this: high current, low voltage power supply. Okay. If you are having some kind of a booster kind of things will be there. That power supply in the nature of what high current and the low voltage, that it is going to charge it so quickly in fraction of minutes. And the customer, they can't wait for hours together. If you charge with your houses, means it may take 8 to 10 hours time period to get fully charged about your battery part. So that high current, sophisticated cables, connector, there are standards of the connectors are required to charge your vehicles. That can be done with the charging infrastructure. This is what that the government is promoting to have. And then industries, you want to increase the some production, means like increase the production, that you are going to make use of the storage system. And then hospital, these are of sensitive loads, that we can say that. In the during the mid of your operation, if power goes, then what is the fate on the human body? Yeah? Huh? That we can imagine that these are of critical loads. I can say that hospitals, domestic users for cooking and maintaining hygienic condition that you require, and the residential apartments to avoid the, means like many issues will be there that you can see that. And then data center, and we want to maintain the continuity of the power supply to your data centers. Yeah, fine. So I am not that much active to make you to be alert in the class, and be attentive for the class. And some of them, they are, it is like a lullaby for them, my class. I don't want to make you to be a lullaby for you and be active. Then the next portion. This is the standard structure block diagram that I am projected here, means for your electric vehicles part. I have focused the main thing, that the here battery part, supercapacitor part, and the second block is associated with the bidirectional DC-DC converter, and it is going to take care of the DC bus and the dynamics associated with the DC bus. And then it will be given to the next level, that is the inverter. From inverter, that will be the AC machine. Or here without inverter, that we can have a standard DC machines also, we will avoid this stage. If you are going to have the more stages, what will be the thing, that the more losses will be there. And here we are mentioning the power flow between the, means what, battery to the this bidirectional converter, or from the bidirectional to the this one. And also this one, that we are going to have some kind of braking part. You are aware that there are different types of braking, that the regenerative braking part will be there, and dynamic braking is there, rheostatic braking will be there. You want to save the energy, okay? By having this kind of architecture, means like we can recover the energy during brake period. Brake period means like what? You have the road condition can be up or down, or it can be of zigzag conditions will be there. Means it is a sawtooth kind of road condition is there. When we are means coming down, what is the thing? Means like can I stop the engine and come down slowly to the end point? Okay, for crawling up we need more power. I will reach the destination. While coming down, I will switch off the engine and can come down. Huh? Is it the good way? Yeah. What happened if I stop the engine and I will come to the down? I can't. I means like if I stop the engine and I will come down because of movement of inertia, it will come on its own. But what happens? No, means like I can apply the brake, mechanical brake I apply. What happens? Can I come? Is it the usual practice in our country? Means like from upside I will apply more force, I will reach the destination while coming down. No, don't talk about the hydraulics. You come to our electric part itself. Now, what happens? Now we are making use of either DC motors, DC machines, or induction machines are there for our system. What happens?
Suppose you are going to use our machinery, like motor or these things, when you are going to turn off the ignition, the steering control will also is unable to control.
Okay. Yeah, one is the rightly pointed. What we can say that the control, we will not get the full control over the vehicle. With the engine only, that you know that you are much familiar about the torque speed characteristic. So with that you will have the good control over the system. Otherwise, it moves on its own way, we will not have the good control over the system. We have to come with the starting the engine only. Then only that means like we can get the control over the speed of the motor, machine's part. That is the thing. Okay. For that, during that process, it may not require the more. It may not require the more amount of current, but only that the voltage maintenance is required. This one. So here that the storage, wide variety of storage technologies means like DC-DC converter, dynamic braking, and also energy and power management. These are the things that it is essential to realize your system. Okay, we have to have. And storage technology, that selection of wide variety of energy storage systems technologies are available. Selection of energy storage systems for a particular application depends on the power and energy rating required for the required application, response time, weight, volumetric conditions. You know that you want to talk about more about the modularity of your system. My system here that you are into that professor is speaking about the high frequency and the low frequency. That what's the basic difference that you can get from high frequency, that the mobile phone that you are having the charger, and the conventional line frequency transformer that you are having. What's the difference that you will have? Yeah, compactness, that the size. Means like if you make use of the line frequency transformer, it is of so big, and then high frequency transformer, it is of very small in what we can say the size. It is compatible. Okay. Here also the same thing, that we will see that the response time, weight, and the value. So we are modularity, that you want to see that if it is of, if there is of any fault in module, we can so easily replace that faulty module and the system can be run. That is one. And these are some of the storage, global cumulative energy storage installations across the globe. We got it from one resource, that is the Bloomberg NEF, and that we projected. These are the things. Now, if you see that the review of storage, energy storage technology, that we will talk, we will store the energy for sustenance, longevity purpose, and I think you have mechanical type of storing the energy, electrical storage, and the chemical energy storage. Okay, and these are of mechanical. You know that this I will talk about this flywheel energy storage system. Okay, and it is well proven and mechanically. What the problem with the flywheel energy storage system? Can we make use the flywheel for our electric vehicle or of distributed energy sources? That the flywheel energy storage system, can we make use to electric vehicles?
Weight is a concern in using pipe.
Okay. Weight is a constraint, and also what? Okay. Okay. And that the one thing I think professor is also here, they are working on this flywheel also. The thing is that associated with the speed, speed is going to very high in the case of flywheel energy storage system. It can be of, we'll talk in, means like in terms of the 20,000, 30,000 rotations per minute. That the bearing has to support that kind of speed. If the speed is more than this one, then the flywheel flies away from the system. So then that is the problem, means like that the power electronic equipment also associated this one. Then it says that electrolytic capacity, means like electrical energy storage, that it is going to make use of the supercapacitor, one thing. What it is going to do, electrofield, it stores the energy in the form of electric field, and then magnetic field. This one stores the energy SMEA, but it is not at that I am saying, it is for only for reactive power compensation, short to purpose, that short duration, that we are going to make use of this SME devices. Even this supercapacitors also, that we can't say that it is provide the means entirely for the longevity duration. Short duration purpose, that the supercapacitor that can be made use, and it is works well with the combination with the other storage device, not alone sustain for long duration. This one. And then chemical, that you are more familiar, that you are having the resources, that the material is available. So then the world is looking on this battery storage system. But lot of research supposed to happen. That you people are talking about this Chinese people and the USA, South Korea and the Europe. They are working on this one battery to increase the capacity of the battery. So that the capacity of the battery, how you are going to analyze the capacity of the battery? Capacity of the battery. If you want to select one battery, what parameters will you look into that? Ampere, and then voltage rating. Yes, that the 12 volts batteries, 24 volts batteries, and the 48 volts battery. And our DC bus system also is that kind of nature. Yeah, fine. 12 volts, 24 volts, and the 48 volts, that will be. And is it made that the one single cell can make the 12 volts? Yeah, one single cell can make the 12 volts. Battery pack, that we'll call it as a, if you want to have the 12 volts battery system, it is a kind of a pack of cells which are connected in series to increase the voltage rating. Yes, that is, you know that individual battery can't give the 12 volts, that you require the small cells which are connected in series fashion to get the 12 volts rating. So then fine, if one man is there, it is very easy to get control. but these are so that the population means like many people are there, how we can get control over them. Yeah, one I want to move fast and other one wants to be sleepy, he don't want to come forward, and another one is doing the average performance. How we can balance? Hmm? That the cells are there, but system is one. System is one. That is the problem that what I am trying to say. Are you getting? Means like that 12 volts is required for us, and there are many cells which are contributing to get the 12 volt. One is performing well, which is near to me, and the other one is not performing, means like in the middle, and the other one is of drowsy. He don't want to react. Yeah, series.
Like series and parallel combination.
Yeah, that series combination will give the higher voltage rating, and the parallel combination current rating, that it is well established. Then okay, that series parallel combination is there, but individually I am talking this person, that person, they are not performing well. How should I do? Yes, that is some kind of balancing technologies that we require to. We have to monitor the individual cell voltages, and then if it is not performing well, then we have to, what's the problem with that? Then we have to identify the problem and get it solve their problem. Okay, balanced way usage of the batteries will one technique that we can say that if we can enhance the lifespan of the battery. That technology, what we are going to call it as a battery balance, cell balancing technology. Okay, this is the cell average performance of the cell that can be taken into the account. Then we'll work on it. That is what cell balancing technology that we'll see that. This is one thing. And then magnetic, no, okay, I can give, and the fuel cell also, that may not be, I can say here that the chemical energy is converted to the electrical energy. What will happen in the battery or of fuel cell, that the one compartment to the other compartment, that the ions are going to move. It is depending on your chemical reaction that the ions are going to move this side during charging part or of discharging part. And in between, that the battery performance will go down because of the chemical degradation, that the quality of the material is going to decompose, and then it won't give the proper performance. That one thing. And also there are some high capacity batteries are there, that I am making use of the single word. I don't want to get in depth about the batteries part. Batteries that I am saying, nickel, cadmium, lithium ion, lead acid batteries, hydrogen batteries, these are of a wide variety of the batteries. As an electrical engineer, I don't want to disturb the chemical, I don't want to disturb the physicist, I don't want to disturb to the metallurgy people. They are working, it is your job, okay, let it be your job. But when it comes to as an electrical engineer, I don't want. My portion is of battery, how to manage the battery. Means like with the increased lifespan, means like that the usage of the power converter. Power converter are going to be helpful for charging and discharging. Okay, that the power converters, what we are going to do, charging and the discharging of the battery, that you can do simply by connecting, but internally what it is happening, that you are supposed to know. That it requires to have a kind of our household appliances is made up of AC power supply. Battery is of DC. In between there should be of a conversion. That conversion, what type of conversion it is going to be? Huh? Rectifier one phase. Okay, that you will get from the rectification, you will get the pure DC. If you make use of 3-phase rectifier or of 6 pulse rectifier, 12 sorry 12 pulse rectifier or of 20 pulse rectifier, can you get the pure DC? But you will get it pulsating DC, you are going to get it. Then you have to stabilize by making use of what? Filter or DC link capacitor, that you will call it. Okay, that the DC one capacitor that can be placed and it eliminates all the harmonic, then the pure DC you will get it. Okay, that if you take the the rating of your household, it is of 230 volts or of 220 volts, that the single phase system. Then the DC obtained is not the, means like around what you can say that the rectified DC? Means like if 220 volts, that the input source. What's the output? Depends on the secondary. No, here you are having the rectifier. Yeah, Vm by 5, that the expression, if you apply, you will get the DC. But my battery is not rated for this voltage rating. Yes, that is the second stage is going to be that what we can say that it is a kind of a DC-DC converter. That the output of your rectifier will be given as an input to the a kind of a step-down converter or of a step-up converter. Okay, to match the voltage of that one to your battery. Okay, this is the stage will be there. So then DC-DC converter. You know that it will be DC-DC converter, you are familiar, and that most of you yesterday's, I think yesterday or day before yesterday's class, their campus wants to have the DC power, DC bus for all the, their campus wants to have the DC power supply. So, DC power supply for all their data centers, all their equipment, they want to have the DC power supply. So, DC is much preferable as compared to the AC power supply. It is a debate also that I can say that DC is more highly preferable as compared to the AC power supply. So, then what's the advantage? That you know that it is portable, more portable than the DC, and we can have the means more portable, that is one thing, it is independent. And then also now because of the advent of this power electronic devices, that we can step up or step down the DC voltages, like step down converter, we will call it. Yes, no frequency component is involved, and also that we may buck operation or a boost operation, it can be. Here also the same thing in the case of this battery part or of supercapacitor part, what we are going to do while charging and discharging. Charging means like what we are going to do for a battery or of a supercapacitor. Now you say that, yeah, now you say that if the battery is fully charged, what does it mean? Or of a one storage element is of full current. Okay. Now I will say that my mobile phone is fully charged. What does it mean?
All the dipoles in the battery is engaged.
Okay. All the
Dipoles.
okay. Oh no, 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 I don't want to be that much complication about dipoles or movement of the that thing, but simple our electrical. Yeah, electric terminology.
Saturated.
Saturated. Okay. Saturation means? Yeah, that the voltage rating of your battery is close to the, means like that the charging voltage of your battery is close to the rated voltage. Then you will say that the battery is a fully charged condition. Okay. Then the voltage rating of your battery is going to be like a rated voltage. Then that is the battery is a fully charged condition. Then it will be means to give the good performance. Okay. That is what. That the charging means here charging operation, how we can relevant this one with the power electronic system. Voltage rating that we have raised to this battery level. Yes?
Depending upon the SOC, state of charge, we are going to plan.
Okay.
Whether we need to charge with the constant voltage or we need to charge with the constant current.
Okay.
It is more than 80%.
No, yeah, you charged the battery. Now the charged the battery. What operation means like you increased the voltage or decreased the voltage. Suppose that you increased the voltage. What kind of operation it is going to be?
Boost operation.
Increased the voltage means like it is of a boost operation, you will say that. If you decrease the voltage, buck operation. These two modes of operation that can be performed with the storage technology. Okay, either it can be of a boost operation or kind of a buck operation. That you are having this single leg inverter structure, off leg inverter structure. It acts like a buck conversion or of a boost conversion that can be exploited, means like for charging and the discharge. So these things that we are having electrical energy, chemical energy and the mechanical energy storage technologies are available. And each one is having advantages and its disadvantages. This is what we can say that. Now if you see that the energy storage technologies and in terms of the efficiency, energy density, power density, life cycle and the response time. Response time also it matters, means like I am not a respondent for your requirement, then what is the use of my presence? So that the response time also very important. Some of the things that among this kind of response time, that the supercapacitor response time is much faster as compared to the other types of storage systems. Okay, lead acid batteries, flywheel, compressed air energy storage system, pumped hydro energy storage system. This chart also what we are trying to project here, that the power density versus energy density. Okay, watt hour per kilogram, means like you see that ultra capacitor, and also we will call it as there are three or four different names of this ultra capacitor, pseudo capacitor, super capacitor, that double layer super capacitor, that we will call it this one. So then SMES over and above, it is having high power density then as compared with the batteries or fuel cells. Okay, even aluminum electrolytes, that it is having the more, what we can say, that the power density. And it can be made use for the short term purpose, not for the long term purpose. This is the means the comparison table which we provided to make you to understand the different types of storage technology. These are, other than this one, you have any other storage system other than this type things, that you have any other storage system? Yeah, fine. Okay. Now we will make it more mature about this technology, because you know that India is the largest exporter of the batteries to the rest of the countries. Okay, even either for two-wheelers or four-wheelers, and our people are smart enough to manufacture the batteries, and then they will export to the even for other developed means other countries. Then this one, that the chart, these are the components that we are going to take into the consideration when you go for the selection of your storage system. Efficiency part, energy density, power density, life cycle and the response time. That the lifespan also very high in the case of a supercapacitor, okay, more than 100 million hours that you will experience, okay. And then this flywheel also, its lifetime is okay, reasonably okay, only it is associated with the mechanical part, that if you can maintain the bearing and that thing, that it will be well and good about this one. This one are of hydraulic, that arrangement, pumped energy storage system 20 to 60 years, and then this lead acid battery, you are more familiar, but the lifespan is very less, okay, 200 to 2000 cycles in their life, okay. So this graph help us to determine the energy storage combination to build the hybrid energy storage system. Okay, why we want to go for the hybrid energy storage system? The efficiency of the lithium ion battery is higher as compared to the other. The efficiency of the lithium ion batteries is higher as compared with the other storage system. It is not so. Okay. The supercapacitor is having highest life cycle, that is greater than 1 lakh, means 100 million cycles. Okay. And then it is having the highest power density because of the absence. Again, I am stressing the point, because of the absence of the dielectric material in the case of supercapacitor, makes the energy means the area to be bigger, that the capacitance is proportional to the what we can say area of the system. Area is bigger, that the capacitance is very big in this case. Then this one efficiency, okay, depends on the choice of storage system depends on the system requirement. Generally high energy density, high power density requirement may not fulfill by using the single energy storage device. The motivation to go for the hybridization of your storage systems. Okay, one single storage element can't satisfy my requirement. Okay, in terms of the response time, life cycle, and efficiency point of view, that's the thing. So then that the maturity of the your things, what we can say, that the supercapacitors are not into the electric. He is saying means like some Europe they are saying that it is developed in there, but in our country it is not so. Okay, they are not clubbing with the batteries with the supercapacitor. That still some means like standardization is going to be required to use the supercapacitors in electric vehicles. Have you come across anything like that our storage system combined with the supercapacitors? No, not yet. I mean to say that I myself also not yet seen, but air air no, air is not the dielectric. Okay, here what we can say that the dielectric material that epsilon naught is there, that the equivalent air is also that the permittivity that will be taken into the consideration. Oh. No, that is a kind of chemical that will be poured in it, and that the more space is available, that the chemical content means silicon carbide kind of material will be there in it, that will be transferred the means like ions will move from one plate to the other plate, that the accumulation is going to ions what diffusion of the ions from one plate to the other plate is going to happen. Not in dielectric in nature. Okay. High power means like that's what we are saying na, in electric vehicle, that is the starting conditions you require the more transients that you do experience in the starting condition. Suppose you are starting your engine from 0 kilometers per hour to the 100 means like 100 kilometers per hour. During that condition you require the more amount of current that can be taken care by the supercapacitor. That graph also I will show you. Yeah. High power and the energy density, when you are having the 100 kilometers per hour means like you will run it, that time that it requires the less power. So then, yes, this is the thing, that the concept of why we want to go for the hybrid energy storage system, this is the motivation. Now, if you see this one, okay, this is the sample, okay, this is the what I mean to say that the internal resistance, equivalent resistance is going to be 0, then it can conduct the more. But it is inductive coil, but we have to maintain the superconducting states, okay, by using liquid helium, liquid nitrogen, we have to maintain the superconducting state. Then only that the storing is going to be possible, and it is meant for the short time power short time power compensation, means like in order to some disturbances is there for 15 seconds to less than 30 seconds, that we can make use of this superconducting magnetic energy storage system. And it also requires, you see that this kind of multi-level inverter, and it is a 250 kilowatt system, 1800 volts, that it requires major component, that the equation stored in the means like high inductance, okay, high inductive coil is required. How many of you seen, means like the maximum inductance in your life? Maximum inductance. That inductance, millihenry, or of at the maximum, that the millihenry is condition that you might have seen. But even if you see that a kind of 1 Henry, that the size is going to be this much bigger, 1 Henry. 7.5, yeah, maximum of 7.5 millihenry, or of means like in terms of the millihenry that you can see. But if you go for 1 Henry or of means like 10 Henry, that the size is going to be very big, okay. And we are supposed to maintain the superconducting states, means like that the cooling system, cryogenically cooling system, and this power conditioning circuit, superconductor coil is required. This is the stored energy equation, means like it is not a rocket, means a big complex equation in the case of superconducting magnetic energy, that the energy stored across an inductive component, stored across an inductive component is taken into the consideration. Okay. These are the things, and some applications: energy reserve, voltage support, reactive power compensation, and then harmonic filtering part. So now it is more somewhat interesting to know more about this thing, and long time that we are seeing this battery pack. Here also that I will give the specifications of this one. This is of 58 farads and 15 volts. Okay. Two supercapacitor bank modules are connected in series to get the 30 volts operation. Okay. That the voltage rating in the case of supercapacitor is of very less. Even small, for getting this 15 volts also, that we externally 2 modules are connected, but internally if you see that 6 cells which are connected in series, here 2 cells, here 2 cells, and here 2 cells. Okay. That makes you to get the 15 volts, that you can divide by 6, you will get around what we can say that 2.95 or something, 2.5, 2.75, that you will get it. Now the problem means like if one person is there, that will be well and good, but more number of individual cells are there, we have to monitor each and every cell voltage, then make you to be balanced, make it to be working conditions. Okay. Is it fine? Okay. Now my way, or can I come to you, make you to be alert? Then is it okay? Once again, fine? Or any queries so far, or anything that you want to pose? The thing. Hmm. Hmm. No, actually we have the theoretical knowledge about this flywheel energy storage system. For me, from our references, this is the content what we have received. Means in the sense that we are not actually working on flywheel energy storage system, but it requires for charging and discharging also, it is going to make use of this power electronics equipment. Any? That in olden days, means like if you take the hydropower plant, that all the hydropower plants are fitted with the flywheel only, not with like conventional battery or of supercapacitor part. Still it do exist, but in practically near to the hydropower plant, that we can see that the flywheel energy kind of storage. Any answer for this one? Okay, yeah, that is the means for hydropower plant, that they are going to make use as per the.
We are going to store the energy in the flywheel.
Hmm.
Suppose we are going to move the wheel, some 25% of the part we are going to supply some mechanical energy. Then by the weight of the wheel, we are going to get high speed.
Yeah, means like if you are storing the energy, it moves to the upward level, and then that it is supposed to maintain then it is stored the energy. And if you want to discharge the energy, that the flywheels will come down and then discharges. Okay, that is the operation. After reaching to the flywheel at higher level, it has to maintain that level.
I think we are going to use while it is discharging,
Hmm.
the motor what we have there, that is working as a generator feedback to the system.
Yes, yes, yes. In that way, a bidirectional way that we are going to make use. Yes, that is, while charging, it moves to the up and maintains that level, and while discharging, it is a kind of circular disc. I mean to say that the circular disc, it moves to the up and maintains that height, and while means discharging, it comes down, and the height it is going to be decreased.
Is operating as both motor as well as generator.
As well as generator. Yes, that is. Okay, this is the theoretical knowledge that we can say that. And then major focus is on our hybrid, means batteries and the supercapacitor part. Yes, fine, we will make a move. Yes, this is the supercapacitor. Now we can say that here that the 6 cells which are connected in series, and that the external connections are provided, and 2 modules which are connected to get the what we can say that is the 30 volts operation, we can say that. Here these are known as ultra capacitors, electrochemical double layer capacitor. Supercapacitor store the energy by accumulating, means it is going to store the energy by accumulating positive and negative charges and store it on 2 parallel plates separated by an insulator. Okay, 2 parallel plates, not the dielectric medium, it is a kind of a insulation will be there. It can be charged and discharged faster than batteries. High power densities, means like this is what watt hour per kg, it is L supposed to be kg, but low energy densities 10 to 20 watt hours per kg. Then supercapacitor is well suited for applications of high power within short period of time, that well known. And then supercapacitors can be arranged in modular system by paralleling and serializing in order to increase the power and the storage capacity. That we are saying that conventional electrolytic capacitor, that you are having the voltage rating is higher, whereas when it comes to here, that the supercapacitor part, that the voltage rating is lower, that you require to have the what, that the series parallel operation is required. That can be done, but it impose some other problem. What the problem? It is going to impose other problem, voltage balancing, that the voltage balancing unbalance is going to experience, that can be made. And then one more beauty of this thing, that we mentioned about the 58 farad and the 15 volts. What about the current rating, that the working current rating of the supercapacitor? Yes, any one of you, that you say that your conventional electrolytic capacitor, what's the current rating of the, means that the working current rating of the capacitor? Current rating that can be operating rating electrolytic capacitor? Milliamperes or of ampere at the maximum amperes that you will get it. Yes, and the voltage is of line voltages, that it can be 1200 volts, that. But here this current rating is going to be very high. This one is made use up to 1200 amperes. 12 I think I have, I think yes, yes. We have yes 1500 amperes, that the maximum peak current for the supercapacitor is of 1500 amperes. That you can imagine that in your laboratories, okay, that the current rating is of, it will not go more than 10 amperes or something, but this with this model, that we can work with the 1500 amperes. Yes, this much size. And what we require, current conditioning circuit is required. We don't have the power supplies which are rated for the 1500 ampere. So then we'll scale down and the current conditioning circuit is going to be employed if you want to make use of this circuit. Okay, that the current conditioning circuit. Then, yeah, this. Yes, sir.
By removing total batteries, can you use only
But bulk modules are required, sir. Means like we can getting the voltage rating, that is, and also it can't be used. Specifically, we have not seen completely taken care by the supercapacitor, but it is not possible, and it.
using a battery pack?
Uh,
Okay, we have only super capacitors.
no, that it is one thing. There are two things that we can say that if you want to completely make use of the supercapacitor part, that the size is going to be very big. That is first part, and the second part is of the cost of your supercapacitor. Means that the cost is of exorbitant. That it is means like not like ordinary electrolytic capacitors. So that the cost point of view as well as the size point of view, it is going to be a bigger. As on date, that it is meant for the short time that we said means like not more than 1 minute time period. Okay, that your transient period, how much time does it exist? Transient period. Yeah, maximum of 30 seconds or of 40 seconds, means like maximum 30 seconds do exist. Then once if it is started, then it moves to the rated speed. That purpose it can be made use. Yeah. So then, yeah, if you come to this portion, that the lithium means like again I have drawn the means that the work with this one 58 farads also for me too much big. What I did, that the series connection, that the 29 farad voltage we increased, minimum voltage this one, maximum, and the equivalent series resistance is of this much. Okay, that we have done. And then available, these are of 6 watt-hour, 58 farad, 30 watt-hour, 5000 farads are also available in the market. Okay. Now when it comes to the battery part, okay, that it is what type of form that it is going to be stored? Chemical energy. It is in the form of the chemical energy. I mean to say that, yes, uh, chemical energy, that we have this kind of battery. Battery is having, yes, Swami, is having any, yes, you have any discussion? You, anything, any points to add?
One thing, sir, basically we are going to use moreover lead acid batteries
Ah.
because of cost constraint.
Okay.
Whatever home UPS, whatever it will be,
Hmm.
we are going with the lead acid batteries.
Okay.
Nowadays the batteries using for the vehicles,
Ah.
for starting purpose all those,
Ah.
lithium-ion battery,
Hmm.
that is for the purpose of the maintenance.
Okay. Yeah, fine. Means like that we are saying again the means that the statement, it is fine. We don't want to disturb the manufacturers about the batteries part. As the electrical engineers, we are the end user. They will give, this is the specification, these are the life cycle, this is the rating of your battery. Then we have to use the battery. Now, this is the performance that we are going to look in terms of the energy efficiency, energy density, power density, life cycle, and the self-discharge. If you won't make use of the battery also, then what happens? That it self-discharges because of the presence of the internal resistance which is present. That itself, even the electrolytic capacitor also, if you won't make use that electrolytic capacitor for some time, okay, then it discharges, self-discharges. Because of what? Because of electrolytic capacitor, you means like if you see the TV, television, that you start and LED, immediately you take off the power supply. LED instantaneously won't come to the off condition. Slowly it takes and becomes completely off. What is the reason? You know, one television that you can turn on the television, then you can watch the movie or a favorite thing of your interest, then you will turn off. Immediately as soon as you turn off instruction to your television, it won't come to the off state, that the LED. LED will take 5 to 10 seconds to completely discharge and become off condition.
Because of the energy stored in the capacitor.
Yes, that energy stored across where?
Across the LED.
Yeah, that LED is there. LED that you are going to make use of a one capacitor is there. That the capacitor is going to have the two types of resistances. One is series resistance and the another one is a parallel resistance. One resistance is responsible for the charging condition and the other resistance is responsible for the discharging condition. Parallel resistance. That is the, you know that the time constant, RC time constant is there, it is responsible. It is not linear, it is like a exponential charge and exponential decay of the charge, capacitance. Okay, this is what it is going to happen. So here, that the lead acid, nickel cadmium, nickel metal hydride, lithium ion, lithium polymer, sodium sulfur, vanadium redox batteries, these are things are there. Some specification that we are going to see, various types of battery technologies and its properties that we are going to see that. This is some data that you will means like we obtain and for selecting the optimal battery for our application, that we can see. So now this is one thing that what we can say that this is the challenges posed by the batteries. Okay, if you make use the batteries part, okay, these batteries, what the challenges? Now I said, means like that the maintaining one is a good performer, one is a bad performer, and the average performer. How you want to maintain all the members in my group? Okay, similar to like our classroom. A good one excellent student, a bad student, and the poor student. Who are going to be my student? Yes, all are my students. My question is that even my professor used to quote this thing. Okay, all are my students only. But you know, as the excellent student, if I tell the concept, he won't follow. Then why means like he knows more than what I am. Then he will say, sir, what sir is saying, it is not applicable for me. He will neglect me. Okay, and poor student, how best that I am trying to convince him, but he won't be convinced. Then what the point of going for the poor student? Then the average students are going to be my students. Means this is they can be flexible to jump to the higher level, or they are flexible to come. But usually, as we are there, they will make them to the next level. Okay, and that is one. Here also the same thing, that we will monitor the individual cell voltages across the, means like how we are going to monitor that the cell voltages by making use of the some kind of sensor, either voltage sensor, current sensor, temperature sensor. These things will be there that we will monitor. If it is not performing well, that we will have some kind of charge discharge mechanism will be there by using the inductance or of capacitor. Then they will brought to the same condition. You see that cell balancing is not taken care by all the electric vehicles and also helps in using the full potential of the battery. Okay, we are, if it is not used in a balanced way, what we will not fully utilize the battery capacity. That we have to have the concept of equalizing the voltages. Once again, that the cell balancing is not taken care by all the electric vehicles. It helps in using the full potential of the battery. Okay, if you are having the balancing maximum voltage, that point also did not come to me. 12 volts that you said, 24 volts that you said, and the 48 volts that you said. Yeah, fine. Even 12 volts we can't manufacture. Okay, then what maximum that the 2 volts batteries are of very standard in high power application. In railway engineering or of substation, that the 12 volt batteries, but the ampere hours are going to be more, not more than 12 volts. 12 volts, if they wants to have the 110 volts DC supply, they will connect the 55 cells in series. Okay, that the 55 cells are going to be in series to get the 110 volts per DC relays will be there for operation purpose. So that the cell balancing technique is of very essential. Why? Means to avoid the chemical degradation or maintaining the under safe operating of the battery, that the cell balancing technique is required. Inconsistency, obviously something we don't know, we can't estimate. It is a complex chemistry of the battery. Okay, how best I design the battery model, I can't predict the behavior. Okay, that even big companies, big personalities are cracking their mind how to predict the behavior of the battery. That the battery, we can't predict the behavior, that how it is going to be react also, that can't be not so easy aspect. And best models also which are there, that even in your MATLAB also that you can find the battery model, but you can't get the required parameters. Okay, only that the current voltage rating, current and the age, that the capacity will be there, but the internal resistance, that I will show the battery model also, that is thing, but you can't get all the parameters what you require to develop the complete model of a battery. Then this one, inconsistency is inevitable for series connected batteries due to manufacturing and usage factor. Okay, different applications. A battery balancing system is effective method to ensure that the battery performance and lifespan are maximized, preventing the battery from overheating, overcharging and over discharging. These are the things: overheating, overcharging and over discharging. This slide, I can say that it is one of my undergraduate student done the simulation work. I am making use of his results. Okay, and good. The person has taken the novel concept to work on this cell balancing technology. Okay, this is what here, that nearly 5 cells are there. He has taken the example, and yeah, individual cells here in A part, that okay, 2 cells are performing at the optimum and the other 2 cells are at lower level, and then this one here something. But here what we are doing in the C and D, that we have, after applying the cell balancing technology, that some of the charge which are excessive in other cell, that can be transferred to the cells which are having the lower capacity. Similarly here also, that the thing that we can see here also, C and D images. So now this is something about the battery part. Batteries, what we are saying, that it is associated with this kind of disadvantages. Only for, it is meant for the energy density. Then we have to go for the hybridization for longevity purpose, for enhancing the battery lifespan. You take one example, what we can say, that LEDs are there. Most of you are aware about the light emitting diodes. This light emitting diode, that the lifespan of the LEDs is more. Lifespan of the LEDs are more. But if you are going to make use of the electrolytic capacitors, that is more than 20 years, that the LED's lifespan is going to be very huge. Okay, that the lifespan of your electrolytic capacitors, what the lifespan of your electrolytic capacitor, not more than, means like 2 years, means like that the number of cycle, that we can say that it is not more than 2 years. Then we have to have LEDs are of stronger and the storage elements are not that much stronger. So that the combination, that there are some topologies associated with the supercapacitors part. Yes, then this one here, most of the applications demand a combination of energy, power densities, cost, life cycle specification, which can't be met by any single energy storage system. Okay. that we require to have the dual storage system. Hybrid energy storage system electronically combined that the power densities out of 2 or more energy storage systems with complementary characteristics. Complementary means like one opposite characteristic that will combine, will exploit the features of those combination. Okay, that the combination of anything, a few examples that I quoted here: supercapacitor, pumped hydro energy storage, SMES, compressed air, flywheel, fuel cell, battery. But here I means like did not mention about the supercapacitor versus battery also. Okay, hence hybrid energy storage system basically consists of high power devices which are of responsive, very fast responsive, and high energy devices, slow response, for example the batteries part. Okay. Now so far anything, now we will enter into the other part. Yes, any query that you want to make or any combination that you want to make, comment? Any?
Any advantage of maintaining those two?
Which one?
Actually, battery maintains two cases.
Huh.
High power as well as high energy. The battery has the ability to supply those two.
Which one? Battery means transient, I mean steady.
Two different cases is there. High power density as well as high energy.
Yeah. It is there. Means like, if I am new, I can, if I am young, I can act. Okay. If I am old, I can't act. Then who are going to be the loser? That the load is going to be the loser. Means like what we are saying, that load is always master, that the follower is of a source. Suppose that the operation means like I don't want means like this is critical loads, that if you are going to take an example, they are in stringent requirement. Okay. If frequently our mics also, that we are putting the new battery into it, I can survive with the old battery also, but in between if the interruption is going to happen, then we are the sufferers for that. Quality is going to be degraded and the lifespan is going to degrade. That is the intention. We don't want to make use of the batteries means like for transient condition. But electric vehicles also, even till today, they are making use of the same thing, but the performance is less than 1 year or of every, I think 2 years, 3 years that you require to replace the.
Vehicles is there, sir.
Okay.
Around 1.5 years we need to change the battery.
Yes, that it is expensive solution as well. Can you offer? I am not that much rich enough to offer the thing. Till even my two-wheeler that I am sustaining okay with the IC based engine. Okay. And then it is the technology is improvising. Now people are talking about this global warming and ozone degradation and green effect gases, all the things. So now the technology is improvising and we will get this thing. Okay. Yes, this is the combination. Any other things from your side? Fine. Now can we move to the next? Okay. Now the power electronics part will come, where how the power electronics is going to play role for this kind of storage system. We have the two different that madam is conveying, that the passive parallel structure, cascaded structure, active parallel structures are there. And you have to have the operation. What we can say that it is storage system 1, 2 and the associated power electronics converter, and the output of this one will be given to your system, or it can be of a load. Or two storage systems are there, separate controllers can be given, and then cascading of this one that will be given to your load network. Okay. Here only one controller is required, but here two controllers are required. Okay. In the case of active parallel structure, that you require the 3 controllers. Okay. 3 controllers are required. So then which one is good? Which one is means like preferable? Yes.
C is the better.
Hmm?
For the effectiveness, C is the better.
Uh-huh.
But compared to
Huh.
I will go with that B.
B. Okay. But my choice is of third one, active, because we want to monitor the individual cell performance. So then it is better to know that what it is happening, that the individual storage system, then separate converter should be there, then it will enhance the performance. Individual cell, individual controller is required and the combiner. If one controller is under failure, then that will be taken care by this third controller also. Okay, that the, but even though it is of some more components augmented to the system, but it is of more effective as compared to the these two. Okay, that we'll see that what it is expected thing in this controller, what it is going to be, that the controller power electronics device or a power electronic controller, what it is going to be. Yes, that is the bidirectional DC-DC converter, that the power flow that can be made from the source to the load or from the load to the source. This is one. And then this converter is there. Then we have to operate this this converter in what mode of operation? Either closed loop operation or of open loop operation. Closed loop operation. If you go for the closed loop of operation, what type of parameters or controllers are required? PI controller is required. Okay, that is a type of a controller, but you know what for PI controller, what parameter that you want to control?
Voltage regulation
Voltage alone?
as well as current.
Yes. So then each converter module contains the two loops. Okay. One is the external controller, another one is of a inner controller. That we will say that voltage controller, and the other one is of a current controller. That the transient that can't be passed from the source to the load side. Okay. That the current controller is there, so that your system is going to be safeguarded. That is what we can see there. Yes, that is always that the current inner, that's what we are saying, that the disturbances can't be transferred from the source to the load level. It can be mitigated at the source level itself. With that, that we will measure the external voltage, inner control, inner current. That we will not take the output current. It is the what input current that we are going to take into the consideration. Outside, yes, that is the output voltage. Okay, that the current is across the inductive component. Inductive component can't be the output current. Okay, you have the one more stage. Yes, this is.
What is the purpose of third controller in the C?
That's what we are saying, na, means like individual to control both these controller, that we have the third controller. Okay, and it can control individually that the storage system 1 and storage system 2, but to control over means like I mean to say that the third controller you are getting two inputs. I want to share the load equally, then I may fix. I want to make the control like this, 25% by one thing and 75% by one thing. That can be controlled by externally. Okay, by setting this one, that we can have the contribution of the individual converter, 25, 75 or 75, 25, 50, 50, like that, 10%, 90%, that depending on your profile. Okay, that the what we can say that the performance profile accordingly, that the sharing of the load is going to take place. Yeah. Yeah. Next. Yes, fine. We'll make a move to the next. Yes. Okay. These are the structures that I mean to say that now with the converters, without converters, number of converters for the different system. That this one is nicely projected by my student only. Passive hybrid energy storage system configuration A and B, and the semi-active hybrid energy storage system configuration C and D, active hybrid energy storage system by E and F. That you know, here in this case that the number of converter, DC link voltage, controlled battery current, controlled supercapacitor, DC link voltage configuration. These are the things that we are going to have. Means like all the time that you know that the flow of the current either from the source to the load or load to the source side. Okay, this one here if you can carefully identify this structure, there won't be any energy exchange among these two. Okay, but we are transferring to the load or load to the source part. Here we can see that, but there won't be, that is the new topic, means like already there, but we are working on the energy exchange among these two sources also. Okay, and here I think he has taken only two sources are here. We may augment one more source as well, means like that one we can keep the PV panel, that is also there. I will show the structure. So these are the configuration, that the number of converter for the configuration A. Here it is not making you any converter. B converter, it is only one converter. Okay, see that if you see that one converter, D one converter, and then this E two converter, and then this one is of one converter. And then controlled DC link voltage, no, here it is not possible. B, yes, okay, yes, yes, yes in all the cases. Controlled battery current, no, no, and here yes, no in the case of D, yes, yes, okay. So controlled supercapacitor current, no, no in three cases, and yes, yes, because separate controller that we are making use. And then DC link voltage swing, less in the case of first four cases, and it is high in the case of last two cases. This is we can say that the relative comparison of the passive, semi-active and active hybrid energy storage configuration. Okay, each and we are going to have the elaborative discussion on the individual converter, that is the bidirectional DC-DC converter, and that the some test performance by injecting some disturbances at the source side and the load side, that we can see. Now the thing, any other things that you want to pose at this stage, any questions? Fine. Now I will show you the simple controller for this one. There are three layers of the control structure that you can find. One is the outer layer, and the second one is of middle layer, and the third one is of inner layer. That you can see that this is the DC bus we are having. Okay, we have power splitting, means like how the power is going to split among the different storage system. Only two storage system that we have taken. What is the percentage of sharing the load? Okay, either battery or a supercapacitor part. Current control, and here that is, here it is outer layer is of external, and the middle layer it is of a power, that will write the control algorithm to split the power level, and the inner layer is of a current. This loop is much faster as compared to the outer layer, that you are already aware. Okay, and then this is the some block diagram representation, and we have only not complex, that the 4 switches are there. That the conventional like means 4 switches that we are going to employ, that the 2 leg structure only, that it is very simple, not that much expensive to build the prototype also. If the switches are of less, that we will go easily for the experimentation. So as a power electronic guy, what you require, that if you want to go for some kind of journal, means hardware results are of mandatory. Okay, it is easy to build our prototype also. So then this thing, inner layer controls the hybrid energy storage system current, outer layer regulate the DC bus voltage. Here that the DC bus voltage, can you expect what's the power level of our circuit? What's the standard that you said, 12 volts, 24 volts, 48 volts, 110 volts? Yes? with this, can you expect? Yeah, obviously means like that the standard, I think 40, not even 48, yeah, less than 250 watts. Okay, our circuit board is of less than 250 watts. Okay, that 3 ampere source we are having, and the 15 amperes DC power supply source is available. Then the maximum of 24 volts or of 48 volts if you take, it is not more power level. That is the beauty of our prototype. Then the middle layer spread the stored energy in the system. Traditional PI, initially we worked with this PI controller, but some advanced controller such as sliding mode controller, model predictive control also applied for that system. Okay. Then this is the somewhat system configuration. Yeah, power splitting strategy, I mean to say that you have the, during the transient condition itself, that you have to reach to the from 0 to the transient steady state condition. During this transient transition itself, if it reaches to the 50% of your period, then the power is going to be shared equally with the, means like some algorithm will make the battery and the supercapacitor can contribute 50-50% like that. Simulation, we will define the means profile, means like voltage and the current profile that we will take, with that only. In place of power splitting strategy, that only that the voltage and the current component only that we are going to take into the consideration. I mean to say that if it power splitting strategy, it is equal, suppose that you have the 10 amperes of load is there. Initial requirement is of 10 ampere source. Okay, that the 10 ampere source I can give it equally 5 amperes to one storage and the 5 amperes to the other storage, other source 1 and source 2, that will be. Or I can give 8 amperes to one source, 2 amperes to the other source. That in that way that we are going to split depending on the profile. Means like if it reaching to the, why we are doing this kind of strategy, to reduce the stress on the storage system. Yes, we have. That I will show you. Okay, that will show you the block, what block we have done for this one, defining this one power splitting strategy. I will show the block. Okay, that period I will show the block. So now this is the idea behind the power splitting strategy, that we want to share the load equally to reduce the stress on single storage system. Okay, then this is somewhat means like here we made use for the AC machine, but you know this is actual our work is on this one, battery and the supercapacitor part, and this is the traditional off-bridge inverter model, and then this one and the exchange to the load circuit. Okay, this forms the complete. I will give the modes of operation of this one. This is what we can see, that either three-phase induction machine or of a synchronous machine you can make use, and based on this one we got the good response by the proposal. And then next, yes, yeah, this hybridization, the importance, active parallel structure is the most widely used one because of its obvious independent control capability. Each hybrid energy storage system has dedicated power conditioning circuit, that is the power electronic, which helps in achieving the variety of control and energy management technique. Only demerit, it is going to be the one high cost, that is what, high cost due to employing two independent power electronic devices for each individual energy storage system. Many multiple input converters have been proposed to decrease the cost of such system. It requires sophisticated control algorithm. Yeah, this is cell voltage rating is very small, series connection of the supercapacitor bank is essential for the higher voltage rating. So, this is what that I can say. Then yeah, up to now, if you have any queries, please let me know, or we can. Any queries? So, many people are not that much well familiarized with this kind of things, that slowly very few people are working on this arena. I mean to say that some IITs and the IIT Madras, IIT Hyderabad, and I think in IIT Mandi also some people are there. So, then it is very I mean to say that demanding arena to work on this energy storage system. They will say that no electrical contribution, but this much the contribution is very exhaustive, vast energy storage system. So, yes, in my next class that I will start with the same thing. This is the proposal. In my next session, I will take the block diagram, some results part, and the power converters that we will discuss on these things. Yes?
There are any constraints to stabilize two different technologies, storage technologies?
Yeah, there are many constraints that the people are not here to listen. Not only in the sense, not I mean to say that if you take the battery itself, battery is they will say that it is a mature technology, but it is not so. If some collapse happens, then who is going to take care of the responsibility? It is like a huge disaster, that the battery explosion, battery accident, battery disposal also. It is a some series of steps are there to dispose the battery. It is not so easy. And then estimation of the performance is also investing, that the experimentation takes long hours to work with the batteries. It is not that much easy. And also that the control algorithm that we are developing, our objective to have this kind of power electronic system to enhance the lifespan of the battery. If you enhance at least for some period, we will save the significant amount of money. Yeah, battery, all the distributed energy sources are fitted with the energy storage system. Without that, you can't sustain, you can't imagine also that do they exist, the distributed energy sources. That is the challenges are more, and also that challenges are more, and the people are working to get rid of those challenges. Yeah, fine. Anything you want to add?
Got the point. You're good teacher.
You want to add that yeah, professor is here, and he has also had worked extensively on these things. He is having more thing that he will give more insight into this storage also, and also good the things. Yeah, fine. We'll break. Yeah, we'll break and we'll continue tomorrow.